Yesterday we talked about the fact that when we're dealing with these light rays and drawing diagrams, we're going to focus on the light rays coming from each end of our object, because if we can see light rays from the ends of the object and nothing's between us and the object, we can see all the light rays in between. All these light rays are coming off the top of the tree. All these light rays are coming off the bottom of the tree, and they are headed in all directions. The ones we're interested in are the ones that made it through the pinhole. So here's the pinhole that you were looking at yesterday. Most of these light rays from the top of the tree don't make it through the hole. This one does, and it ends up here on your screen. One of the light rays from the bottom of the tree, this one, ends up here on your screen and creates an image of the bottom of your object. Because these light rays have crossed paths, and they cross paths pretty close to where the pinhole occurred, you get an image that's inverted. Now, when you looked at the image in activity 1, you were changing the object distance. You're looking at the image that was created when you were close to the object, and you're looking at the image that was created when you're far away from the object. Hunter, how did those two images compare? Okay, so the image that you saw in activity 1 when you were close to the object, when you were about 1 meter away, how did that compare with the image you saw in activity 1 when you were farther away, say 3 to 4 meters away? So when you were close, the image was brighter. When you were far away, the image was dimmer. How about size? Matt, what did you see for size? So the farther you got with your box from the object, the smaller the image got. All right, could anybody tell clarity or brightness? Not brightness, clarity or sharpness of image versus fuzziness. Mitch, could you tell the difference, one versus the other? Okay, so you thought it looked clearer when it was close. Let's take a look at what's going on in that situation. So here we have our object close to our pinhole camera, right here. So there's our object distance. Our image distance is from here to the screen, and we get a nice big object. We move away. Our distance from the pinhole to the screen is the same, so our image distance hasn't changed, but our object distance is much bigger. So here we have a tiny little image. Here we have a much larger image. Is that what you saw? Do you see why the image gets smaller here? The light rays are still crossing, and they still pretty much cross at the pinhole, but different light rays are going to make it through the box, pinhole, when I'm far away, compared to the light rays here. So for activity 1, we're focusing mainly on image size. The focus of the image should be about the same. Turns out focus of the image depends more on other factors, primarily the size of the hole. Since you didn't change the size of the hole, the proportion of light rays getting through is about the same. Any thoughts about why the image might appear less clear in this case compared to this case? Why might the image appear harder to see or less clear when you're far away from the object compared to when you're near the object? There are less light rays making it through. That sounds reasonable. It may not be less sharp. It may just be harder to see because there's less light present. And that's in fact what's going on. The clearness, the sharpness of the image depends on the hole size. If we take a look at this picture, what we're looking at is essentially what you were doing in part 2. So your object distance doesn't change. Your object distance is from the box to the object. Now your image distance is changing. So you have an image distance when you were having the screen close to the bottom of the box, and then you had an image distance where the screen was far away from the bottom of the box. As you move the screen farther away, Chris, which image was brighter for you in part 2? When your screen was close to the pinhole or when your screen was farther away from the pinhole? Closer? Why do you suppose it's a brighter image, Allison, when it's closer to the pinhole, when the screen is closer to the pinhole? So there's more light going through the pinhole when I've got the screen here compared to where I've got the screen there? Good, perfect. More light is not going through the pinhole. What do waves transfer again? Energy. So the amount of energy that the light is depositing on the screen is the same in each case because it's the same number, as Allison said, the same number of light rays getting through the box. So how's that energy distributed on the screen here compared to the energy distributed here? What's different? The same amount of energy coming through my pinhole because I've got the same number of light rays. Here that energy is deposited on the screen there when the screen is close. Here the energy is deposited in the form of an image on the screen when the screen is farther away. Chris said that the image is not as bright when the screen is far away. It's brighter when the screen is close. Can you tell us what's going on in terms of the light energy being put onto the screen in each case? Keep going, you're on the right track. It is having to do with surface area. Good. It's exactly the same principle as we talked about sound waves. The larger the surface area is that the energy has to cover, the weaker In the case of sound, the softer, less intense it is. In the case of light, the dimmer it is. So I've got the same amount of energy covering this area. It's going to give me a bright image. That equal amount of energy now has to be spread over a larger surface area here. So I spread those little energy packets further apart. I don't get as bright an image. So you're exactly right, Hunter. As with sound, it's an inverse square relationship. So I double the distance, it's 4 times less bright. So this is looking at, with reference to activity number 2, when you're moving the screen inside and looking image distance. Activity 3 and 4, you're changing the size of the hole. Mitch, when you made your hole bigger, what happened to your image? Okay, bigger hole, blurrier image. Allison, what else happened to your image when you made a bigger hole? Chris, what happened in addition to being blurrier for your image in part 3? So bigger image, Mitch says blurrier. Do you agree with blurrier? Okay, so bigger hole was brighter. So we got 3 B's. Blurry, big, bright for part 3. Okay, let's see if we can figure out why that's happening. So here is a diagram that we can use to talk about part 3. Now we've got a great big hole here. And we have multiple light rays going through. Before we just had this pair of light rays going through. Now we've got a lot more. Each of these 3 rays is from the top of our object. So I get the top of an object where it hits the screen. So I have multiple positions now for the top of my object. Same is true for the bottom of the object. Here I've got the bottom of the object in 3 different positions. Rather than having the top and the bottom of my object create one position on the image screen, I get lots, which, as Mitch and Chris said, made it look blurrier. Chris, question? You're getting a brighter image, yes. But because now I have multiple spots where the image is forming on my screen, it's not going to be as clear. The edges are going to be a little bit fuzzier, right? I'm looking at a fairly small object. I mean, if I was looking at an elephant or a battleship through that hole and I made it a little bigger, it probably would still be nice and clear. But the object that you were looking at is relatively small. And so essentially what you had when you were looking at it is, rather than just having one F as your image, you had that. So you had multiple images of your object, and they were not quite perfectly lined up. And so what that does is it makes the whole thing a little blurrier. It's brighter, so it's easier to see, but the edges are not as sharp and easy to distinguish. It's a fuzzier image. And sometimes distinguishing between dim but sharp and bright but kind of blurry is difficult to do. So this is part 3. Joe, for part 4, you had 3 holes. What did you see on your screen? Okay, how many images did you see on the screen? 3. So you had 3 images because you had 3 holes. Different sizes give you different brightnesses and clarities. It's exactly what we wanted to have you see. So here would be an example. This is only 2 holes, but the light rays through this hole create this image. The light rays through this hole create this image. And the bigger your hole, as Joe said, the brighter it's going to be, as we saw in part 3, but also blurrier. This is primarily an observational lab. Abdi, since it's observational, what does that mean in terms of error discussion? Pretty much no error. I saw what I saw. If you saw something a little bit different, that's the reason we went through this today, is so that you could identify and compare what you did see with what is really happening with these pinhole cameras. What else do I need to include in my write-up, Jillian? Summary and eval. Okay, summary and eval. We talked yesterday about the purpose. What are we looking for? What are we trying to identify or learn about by using a pinhole camera and the images that it creates? All right. I wanted to shift gears and talk about the camera Obscura assignment. Any thoughts on the pictures? Questions about the video and how they set up the room to be a whole room as a camera Obscura. Could we do that in here? Could we create this room as a camera Obscura? Why not? So there's no outside light coming in. So it'd be a little bit tough because all I've got is hallway light out there. If this were an exterior room, might be able to do it. Interior room, a little tough. Any questions on the assignment, the questions that you were asked to answer? Questions 1 through 4 need to be done and turned in on Edmodo. Question 5, which is doing the sketch, can either be hard copy turned in or Edmodo turned in. It needs to be done by the end of the day. If there aren't any more questions, what we're going to do is we're going to move on and talk about and take a look at mirrors.